Congratulations, really great presentation and great innovative application of technology. The Spaniards used to have this piece of leather they would put in water and just put it on the window as they were driving, and so they have cool wine to drink. I don't know how they did the driving, but anyways, it was very good. So it's the same principle. By the way, I used it myself when I was bicycling. My question is, you have $858 for a box. That has to withstand movements and everything. May I suggest that you use, for example, a standard 20-foot container used for transportation is 8 by 8 by 20. You can get them really cheap because they're discarded in many ways. You can make a modification, and that will be structurally sound to be trucked, and you will have enough things there. Anyways, that was a commentary.
The reason we use our dimensions was because that's the average dimension of a flatbed, so we wanted it to be mounted on flatbeds.
Yeah, but in that case, you will have to make sure that this structurally sound for movement. You won't get it for $858.
My compliments for the name of your team, although I'm an IBIS follower, not a Gator follower. But I do have a number of questions, but because of time, let me say this. You showed a picture which brought back memories to me of the plantains being transported. And it's amazing that that's still happening that way. One thing that I didn't see a lot of work is the fact that different products would require different amounts of labor to store it from the area that you're concentrating, which is from the source of the products to the retail development. And did you look at like the difference between transporting tomatoes or mangoes versus plantains and the work that it will take to store? I would think from being outsider, plantains, it's less laborious to pack it than tomatoes or mangoes to have that product.
So overall, in terms of the work, we weren't too focusing on that. We were focusing more on the value of each. So in terms that should relate to the work is those products are going to be more valuable. And so by using the container and actually being able to transport more of them, you're going to get that value out of putting the more work in there, as opposed to currently now losing about 49% of those produce that you put work into during transporting them.
In addition to answer that question, we also took into consideration the way you're supposed to pack the produce inside the container, because different packing methods result in different convection currents through the container, and such different produce requires certain ways to be packed and managed so it doesn't spoil, doesn't hit, it doesn't bruise. So we took all that into consideration, and I believe it's within the manuscript. We just don't have a demonstration right here of like a RPC container in order to place it inside there to show how it actually works.
Congratulations on the idea, but I have my very serious doubts on the workability of this. What he was talking about in Spain is in a very dry country. I'm an air conditioning engineer. For example, you go to a place like Arizona, New Mexico, that's very dry. People use evaporative cooling for air conditioning. You come to a place like Florida, which the humidity is similar to what you have in Cuba. They don't work. Okay. For example, a cooling tower, which is water being sprayed on top of a thing with giant fan pulling bunches of air, the most you get are 12 degrees Fahrenheit of cooling, which is, what is it? Almost half of that in centigrade. So I just don't see an evaporative system being able to function in a humid climate such as Cuba. And my other concern is how you're going to get the air to flow into the inner part of the container. Obviously, on the perimeter, if this evaporation, I mean, I don't know how you calculated how much cooling you were going to get. Obviously, where you have the perimeter, where you have a lot of airflow when the truck is moving, you would get a certain amount of evaporation. But in the middle of the truck, in the middle of the box, how are you going to get good airflow in there?
So in terms of for the evaporation, as you were mentioning, about 12 degrees Celsius you could expect for decreasing, or Fahrenheit. But in terms of our testing, we did account for the humidity, so the humidity was increased in that room as well. And in addition, the convective cooling and the radiation protection will decrease the temperature further. And as mentioned, a 2 to 3 decrease in spoilage will result just in 10 degrees Celsius. So even if we can't get to that 13 to 15, which is your optimal temperature for the produce, as long as you get that 10 degrees Celsius, you're going to see a huge difference in the amount of spoilage.
And secondly, in order for the air to go into the container, we took into consideration that the air would have to go in through the scoop, and that's where we have the model, the airflow model earlier, that shows that air does go in through the container. It's not in the same velocity as what the truck is going at. However, air does flow through the model, and it does cool down with the fine mist spray.
I congratulate you because this is a very innovative way of, cooling any products. This has been used also in dairy cattle, and it has been a success. So it's just an improvement of whatever environment you will find in any season of the year. So, thank you.
Yes, that's where we actually got the idea from. I work at the dairy farm at the University of Florida, and they have evaporative coolers everywhere. So.
Great. At this time, we can open the floor for one short question from the audience or commentary. If not, we have a question back there. Can you get the microphone? Or somebody can take it. While we get the microphone to Mr. Teo, we have several commentary from our online forum. And I can translate this a little bit for you guys. It's a Spanish. One of the main comments, it says, una excelente idea, congregarse para exponer iniciativas relacionadas a la infraestructura de Cuba. Es importante acudir a la reparación total de la nación lo antes posible. Es crucial. So basically, you have an excellent idea, and it's certainly important to be doing this, what we're doing here today. For Cuba and being able to start collaborating some of the ideas that can be positioned later into a better place so that we can integrate them as this government changes. But Mr. Deo?
Thank you. I congratulate you with the idea. This is very unique. What I was concerned with is the crating of the produce. Let's say that you have tomatoes, which will be very easily to spoil. Then you have to have special crates made so that we allow the flow of the air to go through as well as the entire container. And that way we'll keep the produce fresh. Is this part of the model that you folks work on?
We didn't have access to how if there's any exact crating methods already being used in Cuba. The only information we have is basically what our picture showed of the mass stacking. However, we do know that RPCs would be our reusable plastic containers would probably be the best way in order to form a structure within the container that allows the best airflow. We do have a bit of help from our advisor, Dr. William Pelletier, that shows the best structuring inside, the best stacking form for tomatoes. Those are probably the most delicate, the most delicate to use, and you essentially have to educate the farmers on how to properly do it. Rather than just tossing everything, you'd have to go in in a certain pattern in order to create the best airflow possible.
I would recommend for you to consider that you're starting from zero. Whatever they're doing there, it's not what you want to do. So you have to consider, I will tell them, this is the way that you have to create this thing. This is the way that you have to pack the container so that you optimize the product.
Thank you. Thank you very much. At this time, like we mentioned, we'll take a 15 to 20-minute break. We will reconvene back here at 10:55 to get the show up and going. For those of you watching online, we will come back here at 10:55 with the next 3 presentations. Thank you.